Hello everyone, this is Karthik Reddy, working as an Assistant Professor, Department of ECE, MLR Institute of Technology, Hyderabad. The topic is Joint Probability and Conditional Probability. And the overview of the today's topic is Introduction followed by Axioms of Probability, Joint Probability, Conditional Probability and the problems related to this. The definition of the probability. First we will start with the definition of probability. What is probability? What is the definition? The probability of a particular event. It is defined as the number of favorable outcomes of the particular event E to the total number of possible outcomes. Total number of possible outcomes is the sample space, that is P of S. Okay, means N of E means that probability of a particular event is equal to the number of favorable outcomes of a particular event by total number of possible outcomes, that is called sample space. What are the axioms of probability? What is axioms? Defined as the rules related to the probability. What are the rules and rules related to satisfy the probability condition? Okay, let E be the any random experiment. Let E be the any random experiment. Let S be the sample space associated with the random experiment. Next, what are these? Are three conditions it must be satisfied for the these are also called the rules of the probability. The first condition tells that the probability of a particular event, here A is the event, lies between 0 and 1. Always the probability lies between 0 and 1. If the probability of a particular event, if it is 0, okay, if it is 0, then it is called as impossible event. If the probability of a particular event is 1, then that is called sure event, compulsory occur event. Okay, I will write in the keywords sure event, and this is called impossible event. Impossible event. Now next second axiom is probability of a sample space is always equal to 1. Always equal to 1. What is probability of sample space equal to 1? Means if you take the Venn diagram, this is a sample space. You are having some set of events. When you combine all these events, you will get the sample space, and this is also called as mutually exhaustive events. And next, what is next third one? If A and B are mutually exclusive events. Mutually exclusive means they are not interacting. Okay, they are not having any common point. Okay, like P of A and P of B. There is no intersection between A and B. If S is the sample space, then P of A union B is equal to P of A plus P of B. What is the definition? Okay, P of A union B is equal to P of A plus P of B minus P of A intersection B. But here A intersection B is a null set. Because there is no intersection between A and B. Then what is the probability of P of A intersection B is 0. Therefore, this condition is 0. That is why P of A union B is equal to P of A plus P of B. Okay. If you are taking the case of P of, for example, A1, A2, so on up to AN or mutually exclusive events, then P of A1 union A2, so on up to union AN. If you are considering like this, then what you are going to get the resultant? P of A1 plus P of A2 plus so on up to P of AN. Okay, when you are considering the mutually exclusive events, we can also call this as an additional law of probability. Okay, it can be satisfied when they are mutually exclusive. When there is no interaction, okay, intersecting between any two events, that is called mutually exclusive events. What is the definition of joint probability? Joint means you have already know that joint of two events. That means there is having intersection portion. Okay, intersection portion we are calculating in terms of probability. In terms of probability. What is the, according to the definition? This is the definition. It is obtained in connection with the occurrence of two or more events. It is obtained in connection with the occurrence of two or more events. The joint probability of occurrence of first event, then second event is given by, means probability of P of A intersection B. P of A. Okay, joint probability is denoted by, for example, if your A and B are two events, it is denoted by P of A intersection B. Okay, for example, if you are seeing in the Venn diagram, this is a event A, this is event B. This intersection portion is called joint probability. This intersection portion is called joint probability. It may be two events or three events or n events. Now next, for example, if you are taking an example, okay, rolling a die. What are the total number of possible outcomes for rolling a die? We are having, you may get the combination as 1, 2, 3, 4, 5, 6. You may get the resultant as any one. Next, for example, event E1. E1 is a event having the even phases. If you are having even phases, what are the you are going to get 2, 4, 6. If you are getting odd phases, considering 1, 3, 5, then there is no intersection between event E1 and E2, because one is taking the outcome as even phases and second one is taking the outcome as odd phases. Then the intersection is 0. Then what happens to the union? Okay, for example, if you are taking the probability of E1 intersection E2, which is equal to n of E1 intersection E2 by n of, okay, here you are going to get n of E intersection, okay, this is n of S. Then what you are going to get, intersection portion is 0 by n of S is total number you are having 6, it is 0. Now next, for example, if you are considering the union, then P of E1 plus E2 minus P of E1 intersection E2. Then what you are going to get here? Okay, here number of favorable outcomes. Here you are having 3 by 6 plus 3 by 6 minus 0 by 6. 3 by 6. The total sub, if you do, you will get 1. Now next, we are going to discuss about the conditional probability. Conditional probability we will discuss with an example. We will discuss. Consider a bag consisting of 100 items, of which 80 are non-defective and 20 are defective. Suppose that we have only 2 items from this lot. Okay, you are having 2 conditions. I am taking with an example of with replacement and without replacement. 2 conditions we are going to do. For example, first let the events be A. Okay, first let the event be A. Just I am considering first item is defective. Okay, now after considering, and second item is also defective. Okay, I am taking the first case. If you are choosing with the replacement, means we are taking picking up 2 items. We are picking up first item. Next, we are replacing it again. Okay, when you are doing that, probability of P of A and P of B will be same. Then how many items are defective? 20 items are defective. 20 by 100. 20 C1 by 100 C1. Okay, you will get only 2. 0.2. When you calculate it, you will get 0. If you are choosing without replacement, we are doing that, then you are going to get only particular event A, that is P of A 20 by 100, 0.2. Okay, in this case, if the event A has occurred, then on the second drawing there will be have only 99 items. Total 100 items you are having, left out is 99 items, of which 19 are defective. Total 20 are defective. In that, now one is picked up. Now you are having only 19. Now similarly, The probability of event B is defined by the conditional probability. Conditional probability is denoted by, for example, we are considering the A is, the condition of this is B, probability of B, A is given. A is given. Okay, P of B by A is defined as probability of B if A is given or A is known. A is known. In that case, what you are going to get? Okay, remaining defective is 99 out of total is 99. Okay, 19 by 99. This is represent probability of B given A. Similarly, you can write as probability of P of A by B. P of A by B. It can be read as probability of A given B. Okay, the formulas we will discuss in the P of B by A. P of B by A is equal to P of A intersection B by P of A. You can also write this as P of A intersection B is equal to P of A into P of B by A. Similarly, P of A by B. Okay, in the first case A is known, in the second case B is known. In the second case B is known. It is given in the question that if we are considering A is a event which is known, that is defective. Okay, here B is a event which is known as non-defective. Okay, we can also write this as P of A intersection B, which is equal to P of B into P of A by B. Okay, these are the two definitions which are repeated while we are doing the problems related to, means compulsorily we required at least two events, in that one is known and one is unknown. Next, for example, the same case, okay, we are having special cases. Case 1, if A and B are mutually exclusive, A and B are mutually exclusive, there is no coincide part, then P of A intersection B is equal to 0. When you substitute P of A intersection B equal to 0 in this equation, you will get P of A by B equal to 0. Similarly, if you are taking P of B by A, it will be 0. Then what happens? P of A union B, this term will become 0. Then you are going to get P of A union B is equal to P of A plus P of B. We will discuss with some problems related to conditional probability. What is the probability that 6 is obtained on one dice in a throw of 2 dice, given that sum is 7? Okay, I will read out the question one more time. What is the probability that a 6 is obtained on one dice in a throw of 2 dice, given that sum is 7? Let S is the sample space on throwing 2 dice. On throwing 2 dice, what is the total number of possible outcomes? That is, for a dice 6 power n, this is general representation, n of s, which is equal to, here n is equal to 2, then you will get n of s is equal to 36. N of s is equal to 36. Next, probability, let I am considering as, let A be the event, getting the sum is 7. Getting the sum is 7. What are the possibilities you are having for throwing a 2 dice? You are having how many possibilities? You have to write all those possibilities. What are the possibilities? 2, 5. Tell me, what are the possibilities? 2, 5, 5, 2, 5, 2, 1, 6, 6, 1, 4, 3. Here you are having total 5 possibilities. Okay, total how many possibilities? 2, 5, 5, 2, 1, 6, 6, 1 and 3, 4 is also there. Total 6 possibilities are. Then next you are having the sum. Here you are going to get the sum as 6. Okay, so total sum is 7 of 6 combinations. Next, probability of B is an event getting 6 on any one side of the dice. You are having only 2 possibilities. Okay, 6, 1 and 1, 6. Okay, 6, 1 and 1, 6. Okay, here which is known and which is unknown, you have to identify which is known event. A is a known event. Okay, A is a known event. P of A intersection B by P of A. P of A. Now next, here what you are going to get? Total sum is, intersection portion is how much? Only two combination here. 2 by 36 and P of A is 6 by 36. Then what you are going to get the resultant as 1 by 3. Okay, 1 by 3. This is the way you have to do it. Here first you have to identify which is a known event. They will give you clearly that given that sum is 7, we are considering that as event A. Event A is getting a sum is 7, that is 6. Next, B is a event getting 6 on any one of the dice from the given possibility of the events, that is 6, 1 and 1, 6. When you combine A intersection B, you will get only two possibilities, 2 by 36 by total number 6 by 36, that is 1 by 3. Now next problem. Okay, next problem. A box contains 8 red balls, 10 green balls. Suppose 2 balls are drawn one after other without replacement. What is the probability that second ball drawn is green when it is known that the first ball drawn is red? Next, second ball drawn is red when it is known that first ball drawn is green. First, we have to define the events. First, you have to define. When you define the events, it is easy way to solve the solution. Let A and B be the events. Drawing a red ball in the first attempt and in the second attempt. Next, now we are considering that, okay, red and green both are not depending on each other. I am considering these two are the independent events. Next, probability of A. Probability of A means picking the red ball in the first attempt, 8 by total is 18. 8 by 18. If you are not picking the red ball in the first event, that is, okay, you know it already, P of A plus P of A bar equal to 1. Then what is P of A bar, which is equal to 1 minus 8 by 18, that is 10 by 18. 10 by 18. Next, next what you are having, P of B is equal to B plus B bar, which is equal to 1. Here P of B bar, which is equal to 10 by 17. Next, P of A intersection B. Next one, P of B bar, P of A intersection B bar by P of A. We have to write like this, which is independent, P of A into P of B bar by P of E, which is P of B bar, which is 10 by 17. Next, similarly, here what he had, because in the first case, second ball is drawn is green, and for which when it is known, and the first ball is red. First ball is red and second ball is drawn is green. Now next, A and B are the events in drawing the picking a ball in the first and second attempt. Next, second case, red second ball is green and first ball is also green. Then what you are going to get, P of B intersection A bar, here A bar is there, by P of A bar. Then if we are independent events, P of B into P of A bar by P of A bar, here A bar will get cancelled, P of B will get, P of B is equal to how much? P of B is equal to how much? 7 by 7. Okay, this is the way you have to do it. We have to pick the events. Here I am considering let A and B are the events drawing a red ball in the first and second attempt.